So this video demonstrates the FM modulation capabilities of the HP8640B. I've got it set to 768 megahertz approximately. It's phase locked at frequencies, no modulation at the moment, can be seen on the spectrum analyzer. Got the meter set to FM deviation. It's on the 5 kilohertz peak deviation setting. Now observe the 5 kilohertz. It's got a 100 kilohertz span, so each division there is 10 kilohertz, and the peak deviation at the peak there is about 5 either side of the center frequency, which is where it should be. The dial is set to 5 kilohertz peak, indicates I should be reading on the 0 to 5 scale. It's on 5, and if I reduce the FM deviation down, you can see it'll reduce down to nothing, and 5 kilohertz at the top end there. Increase that to 10 kilohertz, and what this switch then does, it alters the modulation amplifier gain to compensate for the different division in frequency. So we're now up to 10 kilohertz. It's I went over the scale there. It's telling me to go to the 0 to 10 scale again, so if I set it to 10, that's 10 kilohertz peak deviation at the top end there. And then likewise for 20. I'll set the scale on this time on the 0 to 3 scale, so it's at 20. And we're now 20 kilohertz either side of the center frequency. And again on 40. And this time 0 to 5 scale set to 4. And we're now 40 kilohertz peak deviation either side of the center frequency. Now I'll increase the span for the next series of deviations. Let's say 1 megahertz, and go to 80. And on the 0 to 10 scale again, so 8 on there is 80 kilohertz, which you can see 100 kilohertz on this span would be that first division, and we're inside that, so it's 80 kilohertz. 160 kilohertz, and set it again on the 0 to 3 scale. So that's 160 kilohertz to 320 kilohertz. So on the 0 to 3 scale, there's a couple of notches above it, so that's 320. And here we have 1, 2, 3, 320 kilohertz. Let's increase the span again to say 4 megahertz. And go to 640 kilohertz. Not too much deviation there. So go to 0 to 10, 640. So we've got 400 kilohertz, 640 kilohertz either side of the center frequency. Move it to the 1.28, about there, and I've got 1.28. Go to 2.56. I need to increase the span, say to 10 megahertz. I've got the spectrum analyzer on 100 hertz bandwidth, so it's a good definition of the curve there. It makes a span, the span a little bit long to run. It's about 13 seconds to get from one side of the screen to the other. Anyway, I'll go to the 2.56 megahertz setting. And 2.5, 2.56, about there. And I've got 2.56. And finally, 5.12 megahertz. Just about there. And I need to increase the span again, say to 15 megahertz. That's quite a lot of deviation, isn't it? I don't think I'd ever be using anything like that. I'm probably going to use this for 75 kilohertz deviation when I'm checking the VHF band on FM radios. Anyway, we've got 1.5, 3, 4.5, about 5 megahertz, which is correct. So there we go. Every time we switch the peak deviation switch, it alters the FM amplifier gain to compensate for the different divisions of frequency. And actually in this top frequency range here, it's got an internal multiplier in here which is multiplying the master oscillator by 2. So it's actually reducing the deviation, the modulation, to compensate for that change. If I then change the frequency band, say I'll drop this down to say 160 again, but now I'll go down to say, oops, take it off lock. .96 megahertz. That. I set for 160. Reduce the span. 500 kilohertz, say. So I've got 160 kilohertz there, either side of the center frequency. Now I'll leave it at 160 kilohertz, and I'll change the frequency again, and it should retain the same deviation, even though I've changed the frequency. So I'll change the range to 192. I'm now at 192 megahertz, still at 160 kilohertz peak deviation, and it's retained exactly the same deviation. So it's compensated for the division and different division amount from the master oscillator frequency. So it's pretty clever, done by a series of gears and a differential mechanism in there. Anyway, there we go. HP8640B FM modulation demo.